we can say is also a green extraction method, and it is called subcritical water extraction. So the solvent is using water. So previously we have talked about SCF, supercritical fluid, which is based on CO2. And then we also discuss about microwave assisted extraction. And I have shown you the setup. And also this one is subcritical water extraction. These are among three commons being used. So it's for enzyme, it's not something common, so I don't discuss. So subcritical water is using water as a solvent, whereas supercritical SCF, supercritical fluid extraction, is using CO2 as the solvent. So both are considered green solvent, and this whole technique is called green extraction. Yeah. Okay, so I don't discuss the rest of the extraction method because they are not really common, but these three are quite common, especially microwave assisted, ultrasound wave assisted, they are quite common. But the usage of microwave assisted, also the ultrasound assisted, remember that they are still using or probably organic solvent. Okay, so only these two, SCF, supercritical extraction, and subcritical water extraction, is using green solvent. Yeah. So this is how we look at the graph when water is heat up. So you can see that the definition of supercritical before is where the phases between gases and liquid is not really something that you can differentiate at that moment. So this is where water and critical point is achieved between liquid and gas, right? So this is what we call as supercritical water. Okay, let's look at what is supercritical water and supercritical and subcritical, the difference, yeah? So we have discussed I have discussed the last which is on supercritical fluid for CO2. And the difference is if it is supercritical, it is above the critical point. Yeah. If it is subcritical, it is below the critical point. So let's look at the two characteristics of these two. Just straight away to this. So supercritical and subcritical refer to conditions related to a substance critical point. So whether it's CO2 or water, in this case, we are discussing about water, the highest temperature and pressure at which substance can exist in a liquid state. So supercritical refers to a state where a substance is above its critical point, exhibiting properties between a gas and liquid. Subcritical refers to a state where substance is below its critical, where you have distinct difference between liquid and gas. Okay, so if you look at here, when it is supercritical, there is no distinct difference between liquid and gas phases, whereas below critical point, there is a distinct phases of liquid and gas. So subcritical water extraction is an environmentally friendly technique usually used to extract bioactive compound from various sources. including plants and food, microbes. So involve using water at high temperature above its boiling point and below the critical temperature, because this is subcritical water. And the pressure to maintain is and the pressures below the below the critical temperature and pressure to maintain in liquid state. This allows for faster and more efficient extraction compared to traditional method. So back to supercritical, just for you to understand the difference. Above the critical point, a substance exists as a supercritical fluid, a single phase, which properties between a gas and liquid. Okay, like supercritical CO2 that I discussed in the last recorded lecture. So characteristic, supercritical fluids have high densities, solvating power. Remember about the word solvating. In order to dissolve whatever compound or substance, so the chemistry or the chemical process involves solvation. Yeah, that's how solvent can dissolve substance. Yeah, solvation, solvating power, and compressibility, making them useful in various applications. So supercritical CO2 is commonly used in extraction and dry cleaning. Okay, so I have discussed about the SC supercritical, SCF, supercritical fluid, last recorded lecture. So whereas subcritical definition below the critical point, okay, so for example, water just now, the critical point is at 374 degrees Celsius. So if it is below the critical point, then it is a subcritical water. A substance exists in distinct liquid or gaseous state, okay, depending on the specific conditions. Subcritical fluids typically have lower densities and solvating power compared to supercritical fluids. So it has lower solvating power. Examples, subcritical water is liquid water under pressure and temperature above the boiling point, but below the critical point. So this is the difference between supercritical fluid and subcritical fluid. Yeah? So it has, if you look at supercritical, single phase in between gas and liquid, whereas subcritical, distinct liquid or gas, depending on the conditions, depending on the fluid itself, what kind of fluid, density high, lower, solvating power, SCF is much higher, compressibility higher, extraction, chromatography, dry cleaning for the application, because we are focusing on extraction. So both is useful for extraction, SCF and also subcritical. So above critical pressure, below, this one below critical pressure and temperature. Okay. So this is the setup. So this is, for example, the extraction of flavonoids, phenols, antioxidant. Okay, so this is the usage of subcritical water, and the water is heat up until just below the critical point, as well as pressure. It is maintained in a liquid state, but it has greater uh, solvation power in order to extract the useful content of these plants. So subcritical water utilize the unique properties of water at subcritical conditions, high temperature and pressure, to enhance its ability to dissolve less polar compounds. So usually water we cannot use because usually water is polar, it only dissolve polar. But in order to dissolve less polar compounds, we have to utilize the subcritical temperature so that the water have the capability to dissolve less polar. Okay. As the temperature increases, the polarity of water decreases. Okay. So making it more effective at extracting this compound. So in order to use water to extract dissolving less polar, then we have to increase the temperature. So this one you can click and look at the a write-up, a review on subcritical water extraction. So definitely it has benefits of green technology because water is considered green, renewable, reduce the harmful of the usage of organic solvent, making it environmentally safer. So subcritical water can achieve faster extraction methods and higher extraction yields compared to traditional methods. So subcritical water has been used to extract a wide range of bioactive compounds, including antioxidant, phenolic compounds, and essential oils. So this one is very green technique. Okay. So again, advantages over traditional solvent extraction. So you already knew about solvent extraction. So with using the subcritical water, we have lower environmental impact, higher extraction efficiency, potential for higher purity. So this one also being used in food processing, pharmaceuticals, apart from extraction of bioactive compound. So these are the factors affecting subcritical water extraction, temperature. So high temperature lead to increased extraction, but must be careful to avoid degradation of sensitive compounds. Yeah, some compounds are very temperature sensitive or heat sensitive. Pressure is crucial for maintaining water. So this is the one that usually increase the cost. Apart from having to increase the temperature, maintaining the pressure, it is also one of the costly infrastructure in any industrial setup. Extract, even though, but at least um, it cuts down the time and less solvent being used because we just use water. The duration of the extraction process can significantly impact yield and quality. Smaller particle size can increase the surface area for interaction with the subcritical water, leading to better extraction. What does it mean? So the sample that we need to extract with the subcritical water has to be refined. Yeah, you need to grind it to make it greater surface area. The pH of the subcritical water can affect the solubility and extraction. Okay, so we need to play around with pH as well. So I'll be talking about the assignment. So that's it for the subcritical water. I'll be talking about the assignment. So yeah, I know that some of you are finishing your short project and you'll be, writing your thesis. So I understand. So don't worry. So what is going to be happening for your assignment? So assignment 1 from me, I know that Dr. Ili has given you a 30% assignment. Okay, the first assignment will be tutorial-like. Okay, so this tutorial-like will be a series of questions that you need to answer that will help you to enhance your knowledge in this, not just green extraction, because I'll be talking about green extraction, photochemistry, and green energy. So this tutorial will be covering, tutorial question will be covering these three. So you just have to answer and submit in the Putra Blast, okay? So don't worry, I'll be giving the last lecture free for you to do all this work, okay? And the second one is a bit of exploratory, which you answer some, it's not like a tutorial, but it's a bit general questions Okay, you have done this before where you, I will do it in group work because, in order to reduce the burden. Okay, but don't worry, you don't have to record your meetings or whatsoever. So you can just divide your work and the title that you need to present, just a minimum one. Okay, a very short title that you need to present, but you need to do some groundwork, searching for some information, and a bit of slide presentation. Yeah. So I think you also did this in one of my subject before. So you don't have to do a serious study on information, or it's very easy to find. Yeah. So final examination will be conducted based on open book method. So all right, for this time around, we are conducting the final exam based on open book. So some of you, I think I think all of you has done this before with my sense, not all of you, sorry. Most of you has done this before with sensor technology, how we do open book exam. Okay, so I think that's all. Thank you so much. And then for the next lecture, we are going to be back live online for photo chemistry. All right. Thank you.